In this episode of the AWS Developers Podcast, we're talking about AWS Lambda Extension and observability. Good morning. Thank you for downloading the AWS Developers Podcast. We're available all Friday morning with new episode with subjects that matters for developers, especially if you develop on AWS. Today we are recording from the AWS Summit in India, in Bangalore. You might hear a bit of background noise behind us, but that's because we are live here from the expo floor. There are tons of people watching us and listening to the podcast. So thank you for all the attendance of the summit during 2 days. It's a very long summit here in Bangalore. I'm not alone. I'm with Tiffany. Thank you, Tiffany.
Hello.
For having traveled with your microphone and your headset with us to record this episode. And today in the episode, we have the pleasure to welcome Jones. Jones, you're AWS serverless hero. You're also a colleague of us because you're a developer advocate, not at AWS, but at new Relic. And you're an expert into serverless observability. And because of observability, Lambda extension, we are going to talk about that. But why is it such a buzz about serverless observability? What is the challenge to observe, to monitor a serverless architecture or application?
Hey, everybody. And thanks,
Hello.
Sebastian and Tiffany, having me on the podcast. To coming to your question about why observability, especially with serverless, right? Today, serverless is a lot distributed. It's event-driven, it's on the go, and it's not like the traditional system of using EC2 machines, right? Where you have your infrastructure, everything instrumented, and you get in your metrics, you're looking at logs, you're looking at the health of your EC2, knowing that, okay, yeah, my EC2 instance is running fine, but maybe some problem in my application. Yeah. You have that insights with traditional, but serverless is not that. It's your business logic that's being running, and Lambda as a service is, for sure is running, and there are no disturbances or anything such with Lambda service. But your application, there could be challenges. There could be ways or times when it's failing. Be it things like concurrency, be it things like your dependency broke something out, right? And you need to know when things break, because Werner Vogels always says it, everything fails all the time. So you need to know when it breaks, and when it's always, observability is a priority.
Isn't CloudWatch just enough for observability on AWS?
So CloudWatch, I would say that, yeah, the logs are there, but the problem is everything is there and it's finding a needle in a haystack. So with observability tools, there are advanced capabilities that help you pinpoint issues and figure out what really went wrong easily. Okay. So at points in time with production, the faster you identify the issue is also crucial to the faster you fix the issue. So with observability, the faster time to fix the issue because it's faster to identify the issue.
So it's more about making sense to the data that CloudWatch is sending back to. Yeah.
Of course, observability tools still pin on CloudWatch for certain metrics and use those metrics to build more insights.
Yeah,
it's like looking at the logs for one Lambda function, it's okay. But as you mentioned, it's an application is made of several Lambda functions, SQs, S3 buckets. And if we want to trace an event from start to finish, we have to look at so many different places that we need tools to help us. And this is where AWS extensions are coming in. So extension has quite a late addition to Lambda. It came after custom runtimes, after many different API points that we added to Lambda. What is a Lambda extension?
So Lambda extensions is an additional tooling available on top of your Lambda functions, where you can define your own custom functions that run along with your business logic of the Lambda function as processes in the same environment.
So basically, if I want to deploy a daemon inside my Lambda micro VM, I can do that with a Lambda extension.
Exactly.
And that daemon will run all the time. My micro VM is running.
Yep.
And what type of use case it opens?
So since we're talking about observability, remember the time when you had to use containers and having an agent of any observability tool or anything such, you have to have a sidecar, correct? Yeah. Conceptually, Lambda extension is that sidecar.
the sidecar for containers, similar as what we are doing in ECS or AKS. And what type of extension are available today? Observability is one use case. Do you know any other use cases for extensions?
It's governance and security. So there are tools like SEDI, HashiCorp's Vault, also as extensions that help you with governance and bringing in a lot of compliance for your Lambda functions, especially with enterprises, having certain definitions of your security or certain ways how you are doing autonomous scaling of your Lambda functions and everything done at a one single point of time using app config, whatnot. You could use extensions to bring in that compliance to your Lambda function.
So how does it look like? Is there a UI, an external UI, where you like with the Lambda extension, where you can see like all of the things that you observe from your Lambda functions, or like how does it look like?
Well, I'm not a big fan of UI, so I'm very much glad to say that it's not a UI.
Okay, yeah.
But it's the additional code that you write as part of your infrastructure as code and deploy it along with your Lambda layers. And extensions go as part of your Lambda layers, and you deploy it. You set the layer for the function as an extension.
Oh, I see.
So a layer, just to let everybody catch up, it's like an addition to the Lambda environment, like a library that you want to import inside your Lambda environment. You say it's a daemon running alongside with the Lambda process or with the handler process in the Lambda function. Does that daemon has access to the incoming request and response? It's like a filter that will all the traffic will go through that daemon.
Yes, it does have access to all of your network and also IAM resources as part of your IAM execution role for the Lambda function. So it can access all of it. On top of it, coming to requests alone, it can identify what's the invocation request that's coming into Lambda function. Along with it, what's the egress from Lambda function, so that the observability tools can build in that distributed tracing across, okay, this is my Lambda function, this is my external system, or this is my other Lambda function. So to build that complete map of distributed tracing, this really helps to bring in that information.
So it means these tools can enrich the message that the handler receive, or they can modify the response from the handler to the client?
Technically possible, but as a recommended practice, no one does those.
Of course. No, but when enriching, I was not necessarily thinking about the business payload, but like adding additional technical payload, like a trace ID or things like that, adding technical fields in the entry or output of the Lambda function.
Yes, it is possible.
What's the typical language to write Lambda extension? It can be anything running on Linux, because at the end, micro VM it's Linux, or it should be specific languages.
Okay, so here's the thing with extensions. There are two kinds of extensions. There's internal and external extensions. Internal basically runs as the same process of your Lambda function itself. So that is tied to the same runtime that the Lambda function has. So if you have a Node Lambda function, this has to be written in Node. If it's a Python, it has to be Python. If it's external, you have the capability to choose your own whatever you want. Yes.
What do you mean by external, though?
So you can define it as a different process. And internally, it's a firecracker container that's running, right, as a Lambda function. And your function logic is one process. External also can run as another process in parallel to the Lambda function process.
So it's triggered at the end of...
Before of your invocation.
Okay.
So we can talk about lifecycle of...
That was my next question. Let's imagine the lifecycle of a micro VM. So I deployed my code, and there is an invocation arriving. At a high level, the lifecycle is quite simple, but you are going to dive into the complex part. But at high level, the micro VM, it started. The runtime is initialized. That's what we call the core starts, loading all the classes and everything. Then the handler is called. The handler, it's your code. You do whatever you want. And then you return an answer. And if there is no request coming to the same micro VM, we shut down the micro VM for a period of time. That's the high level without an extension. What is the difference when there are extensions, internal or external?
So since you mentioned about the three phases, init, invoke, and terminate or shut down, what really happens with extensions is during the init phase, there is another API, extensions API, that gets invoked. And this is basically to register your extensions. Whenever you have an extension, you have to first register that extension. So that has been subscribed. So Lambda function supports up to 10 extensions at max
For one function.
And you have to register all of these 10 functions synchronously.
Great. So that makes the init phase much longer as well.
Yes.
And customer are paying for the init time. So an extension might increase a bit the bill of your Lambda function for the time it requires for the extension to initialize.
Exactly. So it also adds in a lot of cold start. And now with the new pricing with cold start init phase, this also makes the Lambda function executions a little more expensive. Coming to invoke phase, now that your extension has been registered and has been subscribed, whenever the function is running, as and when telemetry information is generated, be it things like logs, be it things like any other metrics or anything such like invocation of your Lambda function metric, all the typical metrics that you see on CloudWatch, invocation duration, timeouts, and concurrencies. All of these metrics are also exposed using telemetry API during the invocation phase. And this is what the extension uses to receive these information and then run those processes, make those API calls to the observability tool or to CloudWatch. So even CloudWatch is using extensions internally, right? So this is what it does. It uses your IAM permission to write it into CloudWatch log group and get the data using these extensions and telemetry API and write it into, be it CloudWatch log groups, X-ray traces, all of it. It could even be, if you're writing your own custom runtime, it could be any other observability tool.
So that's during the invoke phase. Is there a specific shutdown? Yes, I guess we need to have a clean shutdown as well for the extension.
Correct. So during the shutdown phase, it's recommended for extensions to do all of the cleanup. And top of it, there could be logs that is not sent to your observability platform or a tool or your destination.
Some cache that we need to flush.
You will have to flush that up. Anything that's remaining that has been to send to your third-party system has to be sent during that time, and it shuts down. So your complete Lambda execution terminates when the shutdown is also completed. So there's also little latency after the invocation of your function.
And billing as well, milliseconds of billing. Is there a specific API for the extension to communicate with the Lambda runtime? I'm very familiar with custom runtime. I'm the maintainer of one of the custom runtime for Lambda. But is there a specific API for extension to communicate with Lambda?
Yep. So Lambda service uses two APIs specifically. One is extensions API. That is for all the registry. And whenever there's any event, it uses the extensions API to send it to the extension. There's also telemetry API. Previously, it was called a logs API, and that was specifically for logs alone. Now, recently, I don't know the time frame, but it was very recent that telemetry API was introduced, which involved a lot of traces-related information as well, along with logs. So today, if you're building it afresh, you could directly use telemetry API, which includes the melt aspect of observability, metrics, events, traces, and logs.
And for the invoke phase, there is also an API so that the extension can receive or observe the payload?
So this telemetry API and extensions API is used for both of these things.
Okay, so it's the same the same API. Not everybody should create their own extension, or is it? I have the impression by listening to you that it's only for software vendors, like observability vendors, New Relic, for example, but others as well.
The vendors use extensions to make it more efficient. Of course, without extensions also, we did have observability.
Yeah, but it was a library that as a developer I have to include into my code.
So today it's seamless, making instrumentation for observability easier. But this is not just for observability, right? And you could write your own extensions. One of the enterprise customer that I was having a conversation with, because of the community, you keep bumping into people, and one of them mentioned that they use extensions primarily for governance to ensure that there are no credentials hard-coded in your Lambda function code, to ensure it's either an environment variable or it's an SSM parameter.
So they inspect the code, the JavaScript or the Python code deployed inside the micro VM to verify that there is no security breach. That's smart. I didn't think about that usage of extension. But yeah, it's mostly reserved for a large enterprise that have very strict compliance or security needs, or for software vendor ISV, as you mentioned. The regular Lambda developer that Tiffany and I are probably never going to need to write our own extensions. Most probably.
Well, yeah, I've never created a Lambda extension though, but now that from your explanation, it feels like it's not too complicated to make one. So I would like to try anyway. Yeah.
Is there a good way to start? Do you know any documentation from AWS or template project that we can reuse?
When I was getting started with extension, Julian Wood, one of the developer advocates and Naughty Interface, he has the samples, repo on AWS samples about extensions, and I believe that's a good starting point.
Can you think of a use case where for a single developer, like prototyping something, this would be useful?
Tricky question.
Maybe if you want to format your logs in a specific manner.
Oh, actually, yes.
I know, Tiffany, you're thinking about Bedrock agents.
Yes.
And what you can do.
This is exactly why I was thinking about this, because I use Lambda functions through MCP calls with my agents, and yeah, like it's some of the ideas that I could have. Yeah.
What it means for a user, I mean a Lambda developer, I mean the user of an extension to install an extension. You said that an extension most of the time are distributed as layers, or they have to be a layer. That's the only way to distribute an extension. So what does it mean for me if I'm in front of the console? I know you don't like the console, I can like it neither, but let's start with that to visualize something, and then we can dive into best practice with infrastructure as code. But how to get started with an extension?
Yeah. So with extensions on the console or Lambda function itself, you can still have them as part of your source code. So it has to be...
So layers is not mandatory.
Yeah. It's not a mandatory, but it has to follow a specific directory structure. Don't have that on.
No, but that's not very important. I want
something, ops tasks or something like that, where it has to follow a specific directory structure, and you can have your extensions as part of it. And whenever the init phase, it identifies in the environment variable, you have to mention the paths that the extensions is using, so that during the init phase, it identifies that there's an extension, installs it, and the rest of the things, the process takes care of
automatically. And for the ones that are distributed by ISV, is there a marketplace for extension, or how can I find them?
From the documentation, is a good starting point, because I know the documentation lists all of the ISVs, and it redirects them to the documentation of those ISVs as well. So if somebody's just discovered it, the navigation across going from Lambda documentation to the ISV's documentation is seamless. So yeah.
That's a good news, because sometimes it's difficult to find information in the documentation. Adding a layer, it's just adding the ARN of the layer, and that if I want to use the new Relic extension, I add the ARN of the layer and I guess there is one ARN per region, and that's it.
Yes,
there is nothing more.
So you'll have to. There is a format for the layer on that you just have to include on your Lambda function. Also, with things like CDK and everything, there is ways where you can. Okay, it's not New Relic. This is off the record. So this is something that somebody was building as a custom CDK module to find the latest extension version and get that from the repo.
From a vendor name, for example, to derive the ARN. So it's quite easy to add. And that's the console. What about the infrastructure as code? I guess that there is a CDK construct for extensions as well?
Yes. So CDK, again, you'll be using layers itself. You can define them as the layer on, deploy them, and once you deploy them, it's setting those environment variables, because each ISVs use environment variables, and environment variables are shared across your Lambda function and extensions. So say, for example, I want to send in my telemetry data from my Lambda function to New Relic. I'll have to define my New Relic credentials like API key, account ID. There are certain other configurations, like if I want to enable advanced logging, traces, things like that as environment variables, and that should be good. So it's that easy.
And I guess the extension developer has the choice also to take a configuration from app config or from a secrets manager, for example, to retrieve secrets. Environment variable is just one option that is provided. Because you mentioned the new Relic one, what are the observability capabilities? What can I observe?
So the question is, what do you want to observe, right? Because
I want the weather forecast as well. Is it possible? No, but
well, you could use a API to weather forecast and identify how the API is performing.
No, but I don't know what's the typical observability that your customers are deploying, using. What are they doing?
Okay, this is more of a bird's eye view of what observability is, irrespective of serverless or anything. So there are customers using observability at different layers. If it's a full stack application, you want observability for your front end piece of it. You want observability for your back end. You also want your observability for your infrastructure. So when I say full stack, all of these layers come into play, where you have agents of all of these layers instrumented up and sending in telemetry data. So say, for example, browser, you could know the real-time user monitoring, RUM, as you call it, be it things like page views, the locations from where your page was viewed, the number of times your page was hit, the user journey when they start from page A to page B, C, and say, for example, there's a complete journey that has been errored or something like that. You can find the traces of these things so that when you're pinpointing issues, okay, there was an API invocation done from front end, which went into my backend, and my backend was making a database call or external API call or something. One of it failed, it threw an error, so my backend sent the same error to my front end, right? And your front end error is more front end friendly, so you have something went wrong, like always.
I hate this error message. Every time I want to talk to the developer that wrote that.
So you always think, okay, something went wrong, but you never know what went wrong. And you want in things like distributed tracing, right? And you want to identify, okay, this specific API which made a call, and the backend was making a call to my database on an external API, and the external API or the database threw an error. It could be things like SQL throwing error, right? But somebody who's using the application thinks that, my application is throwing error, but they don't know it could be the database issue. Having observability enables you to pinpoint this issue. Yeah, exactly.
Yeah, observable. Yeah.
A few weeks ago in the podcast, we had a fascinating conversation here in the Bangalore Summit with someone that developed an ETL pipeline as a serverless application, so extract, transform, and load. And she said it was an event-driven application, like a file arrive on S3, it starts a Lambda function that triggers a step function, that triggers Lambda function, that transform the file, drop another file on another S3 bucket that triggers another, and blah, 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 blah. Can you trace this thing end to end? If you want to trace a single file and understand which execution of that Lambda function and step function it match, that's the type of things we can observe.
Absolutely. So I was talking about distributed tracing. This is exactly what distributed tracing does. So it gives you the traces amongst how did the invocation happen across services, across microservices, and also across stacks. So for a fact, knowing that which service made a call to which service, which was a service that errored up, or which was a service that gave a 200 succeed, right? So having these insights is important. And you could be using tools such as X-rays. I know X-ray is natively there. And when you want to use something like event bridge invoking my Lambda function, which invokes my step function, and step function invokes some other service, right? X-ray, you cannot have all of it as one service map. But tools such as New Relic or any other observability tool is able to build you that service map making it easier for somebody to say, okay, hey, something went wrong. Let me take a bird's eye view of my architecture. And okay, you see that errors or the indication it's going in for errors at specific microservices or specific areas of a architecture. You know that, okay, this point or this specific microservice errored, and you start navigating it from there. So you don't have to go from all the way from the beginning. Instead, you can just see the bird's eye view, understand which microservice failed, and start from there.
If you have a magic wand and you can change something in AWS, the Lambda, the API, the service, all the observability world on AWS, what would you change?
Yeah, I believe Lambda function has improved a lot from the time I started using it. I started using it around 2015, 2016. And that was when it was very much launched. Yeah. And I've seen the Lambda's journey in terms of what it is today. I was telling about how UI I'm not a fan of UI because I've seen that UI, but today there is a better UI with the ID experience.
Yeah, there is a full ID, in the Lambda console. You can code directly there.
Yeah. But in terms of what do I really want to see Lambda improve is things where you can debug your Lambda functions right off your
putting local machine, a breakpoint in a Lambda function and step by step in the code while it's executing on the code.
Yeah.
And that would be cool. Yes, indeed.
That's my magic wand. I just want.
Oh, yeah, that's right.
So Lambda team, if you're listening,
Yeah.
I guess you're not the only one asking for that. And yes, because debugging locally, it's one thing. And we can do that. We can simulate a Lambda environment for some use cases. But debugging remotely, it's much more.
Sometimes you do code. You prototype directly there, and it's not too easy to debug there.
Yeah, I mean, you can still do it having all the VPCs set up, having your network egress and ingress set up for your laptop. It is possible, but it's too much of work. As a developer, I would never do so much.
It depends on the complexity of the environment. As you mentioned, if you have VPC back to some resource, it's complicated. It's getting really complicated.
Can we use also Lambda extensions for cost optimization, like to optimize a flow?
Not that I'm aware of.
Yeah.
But maybe in terms of identifying your cost centers. I mean, where, what kind of APIs are expensive, or the SDK calls to AWS, which of them are expensive? Identifying those may be possible, but I don't think you can optimize cost.
Have an insight of what is costing. But okay.
Again, insights and observability about cost.
Yes, definitely.
Unlimited use cases for AWS Lambda extension. Thank you, Jones, for having explained what is a Lambda extension. I hope we give desire to some of our listeners to experiment with that, maybe to build their own extension or to try existing extension from ISV, from AWS partners such as New Relic. I said oops because I touched my microphone and there is already a lot of background noise here. We are recording live from the AWS Summit in India, in Bangalore. Thank you, Tiffany, for having traveling that far. Thank you for having listened to this episode until the end. See you next week for another episode. But now, go build on Lambda, of course.